Our solar system is a fascinating place, filled with celestial wonders that never cease to amaze. Among these marvels is Jupiter, the largest planet in our cosmic neighborhood. This gas giant is a true behemoth, with a mass greater than twice the combined mass of all other planets in the solar system. Jupiter's sheer size is awe-inspiring, and its swirling bands of clouds hint at the powerful forces at play within its atmosphere. Jupiter's immense gravity shapes the orbits of countless objects in its vicinity. Its gravitational influence protects the inner solar system from potential collisions. This majestic planet is also home to a vast and diverse family of moons. These moons form a miniature solar system around Jupiter, each one a captivating world in its own right. Since Galileo's groundbreaking observations, astronomers have identified 79 moons around Jupiter. This vast collection forms a dynamic system, each moon following its own path. Some moons, like the Galilean moons, are large and spherical. Others are smaller, irregular, and likely captured asteroids. All contribute to the intricate gravitational ballet around Jupiter. Studying these moons offers insights into planetary system formation. Kallichore's discovery marked another triumph for astronomical observation, further expanding our understanding of Jupiter's vast and complex system of moons. This faint moon, named after one of the nymphs in Greek mythology, orbits Jupiter at a distance of roughly 23 million kilometers, placing it among the outer retrograde moons. Its retrograde orbit, meaning it orbits in the opposite direction to Jupiter's rotation, hints at a turbulent past, suggesting that Kallichore may not have formed in its current location, but was instead captured by Jupiter's gravity at some point in the distant past. This capture event, a common occurrence in the early solar system, likely involved a complex interplay of gravitational forces and may have left lasting scars on the moon's surface. Despite its relatively recent discovery, Kallichore has already piqued the interest of astronomers worldwide. Its small size, estimated to be only about 2 kilometers in diameter, makes it a challenging target for observation. But scientists are eager to learn more about this enigmatic moon. By studying Kallichore's orbit, composition, and potential interactions with other Jovian moons, we can gain valuable insights into the processes that shaped the outer regions of Jupiter's moon system. Each new piece of information gleaned from this distant moon contributes to the ever-growing tapestry of our understanding of the cosmos, reminding us that even in the vastness of space, there are always new discoveries to be made. The year was 2003. Astronomers, armed with powerful telescopes, explored Jupiter's neighborhood. Their target was the faint objects in its moon system. Led by Scott S. Shepard, they used the Subaru telescope. On February 6th, they found a faint blip of light. It was a new moon, bound to Jupiter. This discovery excited the astronomical community. Unveiling Kallichore, the power of technology. The discovery of this new moon, initially designated as S2003J11, was just the beginning. Astronomers around the world turned their telescopes towards Jupiter, eager to confirm the discovery. They captured additional images of the faint moon, tracking its movement against the stars. These observations were crucial to confirm the moon's existence and determine its orbit. By measuring the moon's position, astronomers calculated its orbital path. The new moon orbited Jupiter in a retrograde direction. This suggested it belonged to the Calm group, sharing similar orbital characteristics. The Calm group is thought to be remnants of a larger body broken apart by Jupiter's gravity. The discovery of S2003J11, later named Kallichore, added another member to this intriguing group. Each new moon discovered provided further pieces to the puzzle, allowing astronomers to reconstruct early solar system events. The name game, a nymph among stars. In the realm of astronomy, discovering a new celestial object is only half the battle. The other half, equally important though perhaps less glamorous, involves giving the object a proper name. This task, often steeped in tradition and mythology, falls upon the shoulders of the International Astronomical Union, the official governing body for astronomical nomenclature. For new moons discovered within our solar system, the IAU follows specific naming conventions, often drawing inspiration from mythology related to the planet they orbit. In the case of Jupiter's moons, the names typically come from the vast tapestry of Greek and Roman mythology, reflecting Jupiter's Roman name, Jove, the king of the gods. Following this tradition, the IAU officially named S2003J11 as Kallichore, pronounced as Kallichore, after a nymph from Greek mythology. Kallichore in Greek mythology was associated with Zeus, the Greek equivalent of the Roman god Jupiter. This choice of name, echoing the mythological connections associated with Jupiter, further solidified the moon's place within the Jovian system. The name Kallichore, meaning she of the beautiful dance, seemed particularly fitting for this newfound moon. Its retrograde orbit, a celestial dance in reverse, set it apart from many of Jupiter's other moons, highlighting its unique and intriguing nature. The name also served as a reminder of the interconnectedness of science and mythology, how our fascination with the cosmos has been intertwined with storytelling and imagination for centuries. Early glimpses and lingering questions. Despite the excitement surrounding its discovery, Kallichore, like many of Jupiter's outer moons, remains shrouded in mystery. Its small size and immense distance from Earth make it a challenging target for observation, even with our most powerful telescopes. The glimpses we have obtained so far have provided only tantalizing hints about its true nature. Based on its brightness, and assuming it has a similar composition to other members of the Calm group, astronomers estimate Kallichore's diameter to be only about 2 kilometers. This makes it one of the smaller moons in the Jovian system, a tiny world dwarfed by the likes of Ganymede, a moon so large it's bigger than the planet Mercury. Its surface composition remains largely unknown, but it's believed to be primarily composed of rock and ice, similar to other members of the Calm group. This composition, along with its retrograde orbit, further supports the idea that Kallichore is a captured object, a remnant from the early solar system's chaotic period of planet formation. While we have gleaned some information about Kallichore's orbit and potential composition, many questions remain unanswered. What does its surface look like? Does it harbor any evidence of past collisions or geological activity? Could it potentially hold clues about the composition of the larger body it may have originated from? These questions serve as a call to action for future exploration, urging us to develop new technologies and observational techniques to unlock the secrets held by this distant, enigmatic moon. In the vast expanse of our solar system, size truly matters. Planets dwarf moons, and some moons could even be considered planets themselves if they weren't circling a larger body. Kallichore in this cosmic ranking falls firmly on the smaller side. Imagine a world so small that you could comfortably walk its circumference in a day. That's Kallichore. Astronomers estimate Kallichore's diameter to be a mere 2 kilometers. To put that into perspective, that's roughly the length of a leisurely stroll through Central Park in New York City. Now picture that entire park squeezed into a spherical shape, hurtling through the vastness of space. That's the scale of this diminutive moon. This small size has significant implications for our understanding of Kallichore. Its diminutive stature means that its gravity is incredibly weak, barely enough to hold onto an atmosphere or maintain a rounded shape. This lack of a substantial atmosphere further contributes to its dark and icy surface, as there's no air to trap heat or moderate temperatures. Kallichore's small size also makes it incredibly faint, a dim speck of light lost in the glare of Jupiter's brilliance. Observing such a tiny object from millions of kilometers away is no easy feat, requiring powerful telescopes and advanced imaging techniques. It's like trying to spot a firefly against the backdrop of a stadium spotlight, a testament to the incredible precision of modern astronomy. Even with our most powerful telescopes, Kallichore's surface remains largely hidden from view. The immense distance, combined with its small size and lack of a reflective atmosphere, makes it incredibly challenging to capture detailed images of its surface. We're left to piece together its appearance based on limited data and inferences drawn from other Jovian moons with similar characteristics. Based on its estimated composition and its position within Jupiter's moon system, astronomers believe that Kallichore's surface is likely a desolate and icy landscape. Imagine a world perpetually shrouded in darkness, its surface covered in a thick layer of ice and dust, pockmarked by countless impacts from micrometeoroids. The lack of an atmosphere means that there's no wind or weather to speak of, leaving its surface features largely unchanged for eons. The only source of light on this distant world would be the faint glow of distant stars and the reflected light from Jupiter itself. This dim illumination, combined with the likely reddish-brown hue of its surface, would create an eerie and alien landscape, a far cry from the vibrant, swirling clouds of Jupiter. While we can speculate about its surface features, the truth is that Kallichore's appearance remains one of its most intriguing mysteries. Future missions with more advanced telescopes or even a dedicated spacecraft flyby could potentially unveil the secrets hidden beneath its shadowy surface, revealing a world shaped by billions of years of cosmic history. Despite the challenges in directly observing its surface, astronomers have been able to glean some insights into Kallichore's composition by analyzing the sunlight reflected from its surface. This technique, known as spectroscopy, allows scientists to identify the chemical fingerprints of different materials, providing clues about the moon's makeup and origins. Based on spectroscopic analysis and its similarities to other members of the CALM group, Kallichore is believed to be primarily composed of a mixture of rock and ice. The ice is likely a combination of water ice, similar to what we find on Earth, and other volatile compounds like ammonia and methane. These ices would have been abundant in the outer regions of the early solar system, where temperatures were cold enough for them to condense and form icy bodies. The rocky component of Kallichore's composition likely consists of silicates, the most common minerals found in our solar system. These silicates, along with the icy components, point to Kallichore's formation in the outer reaches of the early solar system, far from the sun's heat, where these materials could coalesce into larger bodies. However, Kallichore's retrograde orbit suggests a more complex history than simply forming in its current location. Its reverse orbit hints at a past capture event where it was snagged by Jupiter's immense gravity and forced into its current path. This capture event likely involved a complex gravitational dance with other objects in the early solar system, potentially leaving its mark on Kallichore's composition and surface features. Section 4. A distant dance, Kallichore's place in the Jovian Ballet. Kallichore, like all of Jupiter's moons, is caught in a delicate gravitational ballet around the gas giant. Section 1. A rebellious path, Kallichore's retrograde orbit. Kallichore, with its retrograde orbit, is a celestial rebel. While Jupiter spins west to east, Kallichore circles east to west. This backward motion hints at a history shaped by gravitational capture. Its retrograde orbit means frequent, energetic encounters with other moons. Section 2. The CALM Group, a family portrait. Kallichore belongs to the CALM Group, a collection of moons with similar retrograde orbits. These moons are likely remnants of a larger parent body captured by Jupiter. Studying them helps astronomers understand the processes that shaped Jupiter's moon system. The early solar system was chaotic, with planets, asteroids, and comets colliding and being captured. Kallichore was likely captured by Jupiter's gravity billions of years ago. This capture process dramatically altered its trajectory and composition. Kallichore's orbit is a delicate balance of gravitational forces. These interactions can cause its orbit to drift or change over millions of years. Studying these dynamics helps us understand the stability of Jupiter's moon system. Kallichore serves as a window into the early solar system. Its retrograde orbit suggests it was captured by Jupiter's gravity. Studying Kallichore helps us piece together the history of our solar system. Studying Kallichore and other irregular moons refines our understanding of moon formation. These captured moons suggest multiple pathways for moon formation. They provide valuable data for testing and refining our models of planetary system evolution. Kallichore's icy composition makes it an intriguing target in the search for life's building blocks. The presence of water ice and other compounds raises the possibility of organic molecules. Future missions could provide valuable data about its composition and potential for harboring life's ingredients. Kallichore inspires us to explore the unknown and unravel the mysteries of the universe. Future missions and telescopes will continue to study Kallichore and its fellow Jovian moons. Each new discovery brings us closer to understanding our place in the cosmos. Kallichore holds profound secrets about the history of our solar system. Its retrograde orbit speaks of a capture event that altered its destiny. Studying Kallichore and the Calm Group provides insights into the processes that shaped Jupiter's moon system. Kallichore's story, though still being written, highlights the power of scientific inquiry and the importance of exploring the unknown. Each new discovery, whether it's a distant planet, a hidden moon, or a faint signal from the early universe, expands the canvas of our knowledge, revealing the intricate beauty and complexity of the cosmos. The study of Kallichore and other irregular moons has challenged our assumptions about moon formation, prompting us to refine our models and consider alternative scenarios. It has also raised intriguing questions about the potential for these icy worlds to harbor the building blocks of life, adding fuel to the ongoing search for life beyond Earth. Furthermore, Kallichore's discovery serves as a reminder that our solar system, despite centuries of exploration, still holds many secrets waiting to be unlocked. Future missions equipped with advanced telescopes and spacecraft promise to unveil these secrets, providing unprecedented details about the composition, history, and potential habitability of these distant worlds. As we gaze up at the night sky, our eyes drawn to the familiar glow of Jupiter, let us remember Kallichore, a tiny moon with a giant story to tell. Its discovery, a testament to human ingenuity and our insatiable thirst for knowledge, inspires us to continue exploring, to push the boundaries of our understanding, and to embrace the unknown with a sense of wonder and excitement. The universe is vast and full of mysteries, and Kallichore is just one small piece of the cosmic puzzle. But within its icy depths and its chaotic orbit, we find echoes of the early solar system, clues to the processes that shaped our cosmic neighborhood and the countless other planetary systems scattered throughout the galaxy. As we continue our exploration of the cosmos, let us carry with us the lessons learned from Kallichore, a reminder that even the smallest and most distant objects can hold the keys to unlocking the universe's greatest secrets. The journey of discovery is never-ending, and a universe of wonders awaits those who dare to explore.